So this is the day 25 worksheet. This is the PDF of my answer key. I thought I would talk through the ones that I didn't talk through in my previous video. So I talked through number one. Again, we went through that there were a couple different ways that you could do it. Same holds true for these. Again, a lot of times there's different options that you have. You could start from the other side. You could manipulate them a little bit different, but you do obviously have to follow all the rules of our identities and a lot of algebraic rules. As I've been looking through some of your homeworks that you guys have turned in, and some of you have asked me to look at certain problems on there, I've noticed a lot of like algebra mistakes, just multiplying mistakes or canceling things out that can't be canceled just because you kind of want them to cancel out. So let's take a look at number two. So there is a shorter way and there's a longer way. I'm actually going to talk through the longer way first. Again, glancing through some of them, I saw a number of people started doing it this way, so I thought I would talk through this way first. I started with the left-hand side on both of them, really, because the left-hand side is the more complicated way, or complicated side. Sine x, there's not, or sine of theta, there's not a whole lot to do over there. So for the left-hand side, one option would be to look at this denominator, kind of what we had done in the very beginning of number one here. If you have a 1 plus the secant of theta, you could multiply it by 1 minus the secant of theta, but you have to do it on the numerator and denominator. Now, here's the key that, again, I was noticing a number of people making mistakes on. When you're multiplying the numerator, you have to multiply the entire numerator, not just the tangent part of it right there. So then in the denominator, we get 1 minus the secant squared. Now, on this second part, or on the next step here, the secant squared I replaced with our trig identity, our Pythagorean identity of the tangent squared plus 1. So then the 1 and then the minus 1, because again, when we distribute that negative, those cancel. We get a negative tangent squared in that denominator right there. Now in the numerator, I multiplied everything out. Again, it's not just the tangent being multiplied, it's the sine plus the tangent. So I distributed. So we get the sine and then minus the sine times the secant plus the tangent and then minus the tangent times the secant. So that was everything multiplied out in that numerator. So again, this way's a little bit messy here. We've got a negative tangent squared in the denominator. In my numerator, I'm like, okay, well, really eventually I want to get to just the sine. So is there anything else I can kind of get rid of here? So when I looked at this here, I changed the secant to 1 over the cosine right there. So right here. And then I changed on this part, this tangent and this secant to sine over cosine and 1 over cosine. Quite honestly, I could have absolutely changed this tangent right here to sine over cosine. I don't really know why I didn't. Either way, though, this sine over cosine, it's negative sine over cosine or negative tangent. And then this is the positive tangent, or again, positive sine over cosine. Either way you did it, those are going to cancel out right there. So then I'm left really with the sine minus over here, the sine over the cosine squared. Okay, so then when I looked at it, I'm like, all right, I got to look at this numerator. I cannot just start canceling. I'm, again, seeing some people go, oh, well, sine over cosine, that's the tangent. I can cancel stuff out. You can't just start canceling things out here because, first of all, both things are being divided by the negative tangent squared. But also, again, we got to think through that numerator carefully right here. That's just a sine over cosine squared, not sine squared over cosine squared. So what I did, in that numerator, I got a common denominator, so I multiplied right here by cosine squared over cosine squared. So I got sine times the cosine squared, now minus the sine all over the cosine squared. So because this is one big division problem, if we're dividing a fraction by a fraction, I multiplied by the reciprocal right there. So if we multiply by the reciprocal of the denominator here, that's cosine squared over sine squared, still negative right here, notice. Notice that those cosine squareds cancel. I distributed the negative right away on that, so that's why I got negative sine cosine squared and then positive sine right there. So again, this is the long way. And then once I did that, I'm like, okay, well, my ultimate goal is, again, we want to get the sine. So I'm going to see if I can start canceling some stuff out. And I saw if I factor out a sign, I can be left with 1 and then minus cosine squared, which is the sine squared. So now we have a sine squared in the numerator. This is sine squared divided by the sine squared in the denominator. Those cancel, and we get the sine of theta by itself. So again, that way is much more convoluted. There might have been other things you could have done to shorten it. This again was just one way that I came up with as I was going through. Kind of the hard part about really teaching these is there's lots of ways to do it, and you kind of just have to play with it. Like I can show you a million different ways to do a problem, but you may come up with something different. Or again, you really do just kind of have to think through them. Let's look through the shorter way. So if you looked at this, again, when I kind of look at this, I'm like, all right, my ultimate goal is to be the sine. So maybe let's start with the left-hand side, trying to change everything into sine and cosine. Really, that's kind of a good strategy if you're stuck. Everything can be changed in terms of sine and cosine. Like secant is 1 over cosine, cosecant is 1 over sine, tangent sine over cosine, and cotangent cosine over sine. So everything can be changed into sine and cosine. So that's what I started with here. So the sine plus the sine over the cosine, and then over 1, or over the 1 plus 1 over cosine. So I changed the tangent and the secant. Now, a couple things you could have done from here. You could have gotten common denominators on both of these. But when I looked at it, I'm like, well, okay, look, this entire numerator, my common denominator, would be the cosine. And this entire denominator, the common denominator, would be the cosine. Again, so I'm like, well, if I can look at this whole fraction and just multiply the numerator and denominator by cosine, that would cancel out this cosine right here and give me sine cosine, because I'd still have to multiply it to both of them here. So sine times the cosine, and then plus just the sine. And then same thing here, I'd have to multiply it to both of them. That would be cosine plus 1 right there. So now I have the sine times the cosine plus the sine over the cosine plus 1. So in that numerator, I saw that there's a common factor of the sine, so I took that out. Was left with cosine plus 1. Now we have a cosine plus 1 in the numerator, cosine plus 1 in the denominator. Those cancel, and we get our just sine of theta by itself. Again, there's other ways to go about it. In that numerator, you could have gotten common denominators, then multiply by the reciprocal and get rid of the cosine that way. There's lots of different ways that you could kind of go about doing that one. Let's look at number 3. So number 3, again, really, I would say you could very easily take either side here, start from the left or start from the right. I started from the left-hand side, so I'll explain that way that I did here. So we've got tangent squared times the sine squared. So again, I thought, all right, well, let's just look at this and see if we can try changing any of these into sine and cosine. So tangent squared is the sine squared over the cosine squared. Then in our numerator, we do get a sine to the 4th, but that doesn't, really help us with anything. So I thought, okay, if I have a cosine squared in that denominator, what if I try changing one of those sine squareds to 1 minus cosine squared? Now, the reason I just picked 1 is really I still do want a sine squared somewhere in our problem. So I thought, let's just try changing one of them right there. So 1 minus cosine squared, again, everything in parentheses here, times the sine squared. So when I did that, I said, okay, well, I can distribute here. And I get the sine squared, minus the sine squared times the cosine squared. And again, we have just one denominator here. Our goal is to have a minus. Now I have a minus here, so let's separate them. So sine squared over cosine squared, and then minus the second half of the fraction, sine squared cosine squared over cosine squared. Notice those cosine squareds cancel. We get our sine squared back again. And then sine squared over cosine squared is the tangent squared there. I'll go ahead and, you know what, I will do a different version from the right-hand side here in case you dealt with that side instead here. There's a color that we can see a little bit better here. Sorry. Okay, so when we look at this one, or not, When we look at this one here, again, our ultimate goal is to get them to be something multiplied, but you can't just, magically make them multiplied here. So let's think through what we can do. So I'm going to kind of start it similar to how I started the other one. I'm going to change things into sine and cosine. Okay. And again, we want things to be multiplied. So that means I want to really combine this into one fraction right now. So that means I'm going to multiply numerator and denominator by cosine squared here, so that way we have a common denominator. So sine squared minus sine squared times, oops, forgot the theta here, times the cosine squared here over cosine squared. Okay, so now we've got this here for us. Now we're at least in like one term right here, but we want to again somehow kind of combine that numerator together. So I see that there's a common factor of sine squared, which leaves us with 1 minus cosine squared right here. And here we know 1 minus cosine squared is the sine squared. Okay, so now we've got everything multiplied. Notice we've gotten rid of any adding or subtracting in this, which is good because the left-hand side has no adding and subtracting. Now, because this is everything multiplied, I don't need to think like both of these are being divided by that cosine squared. If that was a plus, you would need to make sure you have that. But because it's a times, I could just rewrite this like this, the sine squared over cosine squared times that. Again, if that is over 1, that's equivalent. Now, sine squared over cosine squared is the tangent squared. Sorry, I'm just kind of out of room here. But we get tangent squared and then times the sine squared, and that equals our left-hand side. Okay, so just another option for you if you worked with the right-hand side instead. Okay, let's take a look at some of the review problems. Number 4 I had done in my previous video. Number 5 is similar. We have to, this instead of having the times 2x, here we have a translation. Phase shift is what it's called here. So I have my interval from 0 to 2 pi. If I add 3 pi over 4 to every part of that interval, we get this new interval that we're looking at. Okay, so this inside part, the x plus 3 pi over 4, again, we want to know where is the tangent, the square root of 3. So tangent's the square root of 3 at pi over 3 and 4 pi over 3, just on our unit circle. But we really have to think about where is it on this interval right here. So pi over 3, 1/3 is less than 3/4. So that's not one of them. But if I add 2 pi to that, so 6 pi over 3, that gives us 7 pi over 3. 4/3 is in this interval. 4/3 is 1 1/3. That's bigger than 3/4, and then smaller than 11/4. Again, 11/4 would be what? 2 3/4 there. So this then would fit in there, and this one would fit as well. This would be 2 1/3. If I tried to go one bigger, if I added the 6 pi over 3, that'd be 10 pi over 3. That would be 3 1/3. That's too big, so we only have these two numbers here. This is just me getting common denominators, a common denominator of 12. So when we subtract 9 pi over 12, we get our two answers there. Okay, so kind of similar. Then finally, number 6 and 7 here. So for number 6, we've got kind of a multi-step problem. Notice that this is a 2 times that whole thing right here. So 0 is less than or equal to x is less than or equal to 2 pi. So again, you have to think about order of operations. You have to subtract 5 pi over 3 first, so 0 minus 5 pi over 3, then multiply by 2. That gives us the negative 10 pi over 3. 2 pi minus 5 pi over 3, that would be, 6 pi over 3 minus 5 pi over 3 would be 1 pi over 3, but times 2 would give us 2 pi over 3 here. So this is our new interval that we're looking at. So we want to know where's the cosine negative root 3 over 2. in both of these positions over here. That's at 5 pi over 6 and 7 pi over 6. Neither of those are in this interval here. 5/6 is bigger than 2/3 there, so that's one's not even fitting there. And so that means 7 pi over 6 most definitely is not. So we have to subtract 2 pi. So if you subtract 2 pi, or 12 pi over 6, we get negative 7 pi over 6. That one fits. Negative 5 pi over 6, if I subtract it from here, fits. If we keep going here, if I subtract it again, that gives us negative 19 pi over 6 and negative 17 pi over 6. Again, double check that they fit in here. This would be negative 3 and 1/3 right here, pi. And then right here, this one fits, that would be negative 2 and 5/6. So all of those fit. So we've got 4 answers here. So now I divided everything, again, except for these two, I divided everything by 2, which is the same as multiplying by a half. That changes our denominator to 12. Then this was me getting a common denominator here. We're adding 20 pi over 12 to everything here, and that gives us these answers. This was just me putting them in order from smallest to biggest. A lot of times you will see your answers in order from smallest to biggest. Again, we just reduced this one and reduced this one, and I just put them in order from smallest to biggest there. Okay, now the last one. This is one that is a little bit different. Now, I know it's different than my last three because there's a sine and a cosine. So we can't set it up exactly the same way. I can't say, oh, 2x is equal to, like pi over 6 or something like that. You can't treat it the same way. Cross that off here because it has a sine and a cosine in it. So that's when I know, all right, I'm going to have to think about some identities on this one. So this is one of our double angle identities. There really is only one for the sine of 2x. So there's no other options than just 2 sine of x times the cosine of x. Now that equals the cosine of x. Now, one thing I notice about these is that they both have a cosine of x. You can't just like divide that out and get rid of it, but I can subtract it from both sides. And again, they have a common factor of cosine of x. So I factored that cosine of x out, and we're left with the 2 sine of x minus 1. So now the cosine of x is 0, or the sine of x is 1/2, and we get our 4 solutions that way. Okay, let me know if there's any other questions. Hopefully it helps to kind of talk through some of them. And again, email me or message me on Classroom, and I'll try and help out wherever I can. Thanks, guys.